All right, we're rolling. So one of the things you guys looked at yesterday was central angles. Okay, so let me just clarify what a central angle is. Very simply, it's an angle with its vertex at the center of a circle, and its sides are radii. Okay, radii is just the plural of radius. Okay, so a single radius would be that. You put two of them together, you call it them radii. The angle that they form is a central angle. All right. In this case, you have another central angle over here with the 130-degree angle, and a final central angle down here with this x. Hopefully it makes sense that all central, or let me say it this way, the sum of the central angles in a circle is 360 degrees, okay? So all three of these central angles, as long as they're not overlapping angles, okay, would add up to 360. So in this case, to find the measure of angle x, we would simply add 60 and 130 to get 190 degrees, subtract that away from 360, and you get 170 degrees for your angle x. Okay? So, pretty straightforward. Moving on to the next one. Another thing you guys looked at was minor arcs, major arcs, and semicircles. The biggest new thing with this, guys, is that you understand some of the notation. Number 3 asks for the measure of arc IHJ. Okay? There are 3 letters there, obviously. When there are 3 letters there, you have to follow those letters in order to identify the arc you're talking about. So you start at point I, and then you follow along the circle towards the direction of point H. So we're going towards H like this, and we just continue around the circle until we get to the last point here of J.
Major arcs.
Okay, so that arc looks like that. It's, again, an arc is just part of a circle. And obviously in this case, this is a major arc. Major arc because it's more than halfway around the circle. Okay? Hopefully that's, again, pretty straightforward. This one here only has 2 letters to it. Okay? Only 2 letters. So the thing to recognize when you only have 2 letters to name an arc is that you always go the shorter distance to identify the arc. Okay? Someone might say, well, Mr. Cundy, you could go H-I like this, okay? Well, yeah, but when there's only 2, it's always understood that you go the shorter distance, okay? So it's always a minor arc. Okay. And lastly, HGK, the measure of arc HGK starts at H, goes to G, and then to K. You'll notice that goes exactly halfway around of our circle. We call that a semicircle. Okay. That's pretty much it. We're going to talk about measures on the next slide here, but those are minor arc, major arcs, and semicircles. Find the degree measure of arcs now. Okay, so we just looked at finding the arcs. Now let's look at something called their degree measure. Okay, so first of all, where is arc STP? Well, S, I got to start at that first letter, then I got to follow it in the direction of the second letter, which is to T, and then to P. Okay, so that right there is arc STP. What is its degree measure? Well, the first thing I want you to understand is that every arc has a central angle that kind of goes with it. Okay? You guys see if I make a central angle here, with a radius that goes out to point S and a radius that goes out to point P, I kind of enclose that arc with the central angle measure, okay? That central angle measure has a sum of 147 degrees. And the corresponding arc has the same measure, okay? So let me summarize that. The arc measure and the corresponding central angle measure are equal. Okay. So if this central angle measure here is 147, the arc measure is also 147. Thank you for your continued attention. I have 2 more slides here, okay? Inscribed angles. This is an inscribed angle right here. Instead of the vertex being at the center, like a central angle, we move the vertex on the circle, and this angle is considered inscribed. The sides are called chords, and we will talk more about that another day. Just said chord, okay? But that's an inscribed angle, okay? Now, notice that this inscribed angle, these other ends intersect the circle and kind of keep, or what should I say, kind of open up to an arc, okay? And I'm just going to call this R, let me call that arc RJ, arc RJ, okay? And let's say that it has a degree measure, just like we talked about before. Let's say this degree measure is 120 degrees. Okay. If that arc has a measure of 120 degrees, there is a relationship between that arc and the inscribed angle that it kind of comes from. Okay. You guys remember what you saw yesterday on what that angle measure was here?
It's half.
Angle, so RTJ. It's what?
It's half.
It's half, yeah. So whatever this is just half of it, okay? And so, again, we could talk more about why that is sometime, but you guys saw that in your exploration yesterday, I hope. But that's the key thing, right? The inscribed angle and the intercepted arc, or the arc that it opens up to, the inscribed angle is half of that measure. Okay? We got one more. Can you hang in there for one more slide?
Think so.
Think so? Okay. This actually is a new thing, okay? So I wanted to show you one new thing that you did not see yesterday, and this has to do with the lengths of arcs, okay? And so, question number 10 is asking to find the length of arc JK, all right? So what are we talking about when we talk about the length? Well, understand 2 things. JK, right now we've already talked about arc measure. We've talked about an arc measure, that the degree measure of arc JK. Remember how we said that was the same as the central angle measure? I already told you that a few minutes ago. So because this central angle measure is 30 degrees, the arc measure of JK is also 30 degrees. Okay? However, there's another thing that you can do with the arc, and that's find the arc length. How is that different? Well, It's like taking a tape measure that's flexible and actually measuring how far that arc is. And you can imagine if we get a bigger circle, can you imagine that arc's going to get longer? Even though the angle would stay the same. Here, let me even try this. I don't know if this is going to be messy or not, but okay. Imagine a bigger circle here with the same central angle measure here, right? Do you see how this arc out here on this bigger circle would have the same arc measure? It'd still be 30 degrees because that's the central angle. But do you see how like actually a tape measure around that, this arc length would be longer than this arc length? With me on that? Okay. Now, how do we figure that out? That's the question here. So let me get rid of that. So the arc length, we kind of already know a little bit of how to find the length around a circle. Because I think we've already talked about how to find this whole length around there. What do we call that? Circumference, okay. So we already know the circumference is 2 pi r, or pi times diameter. So what if we did this? What if we just found the circumference, 2 times pi times the radius of 2 feet, but we don't want the whole thing, do we? We only want a fraction of it. So we're going to multiply by a fraction. What fraction of this do we want?
30 over 360.
Yeah, we only want this little 30-degree slice out of a total of 360 degrees. So if you ever want to find length, you just take the circumference and multiply it by the fraction dealing with your arc measure over 360. And then from here, class, it depends on what form the question's asking for. I'm just going to show you an exact form here. I could multiply the 2 and the 2 to get 4. Keep the pi. 30 over 360 is 1/12. And then I could take 4 times 1/12, which is 4/12, or 1/3. And I could bring the pi along. 1/3 pi feet. Okay? Now, you can also just type this into your calculator. And when you do that, 2 times 3.14 times 2 times 30 over 360, get parentheses around that, you get 1.05 feet. So sometimes they'll ask for a rounded answer like this. Sometimes they'll ask for an exact answer like this. Yeah?
So like on a test, which one would you prefer? Or is there just...
I will be clear on that, okay? I don't know right now.